Chemists use valence shell electron pair repulsion, or VSEPR theory, to account for the shapes of molecules. The theory is based on the idea that like charges repel each other until repulsions are minimized. The like charges in this case are the groups of valence electrons around a central atom in a molecule or ion. We'll represent them as bars attached to a sphere and show the electrostatic repulsions as yellow arrows of varying width. The simplest case has two negative groups around a central atom. At any angle less than 180 degrees, electrostatic repulsions push the bars apart. Repulsions are minimized when the bars attain a linear arrangement. Electron groups can be single bonds, as in gaseous beryllium fluoride, double bonds, as in carbon disulfide, triple bonds, as in hydrogen cyanide, or, as you will see shortly, lone pairs. Three negative groups attached to a central atom attain minimal repulsions in the trigonal planar arrangement, which has an ideal bond angle of 120 degrees. We observe this angle in molecules with three identical groups, such as boron trifluoride and sulfur trioxide. Molecular shape is determined by the positions of atoms, not electron pairs. Therefore, if one of the electron groups is a lone pair, the molecular shape is not trigonal planar, but bent or V-shaped. Since a lone pair is held by only one nucleus, it is less confined in space and exerts greater repulsions on nearby bonding pairs. As a result, the bond angle is less than 120 degrees, as you can see in this model of ozone. Four electron groups around a central atom attain minimal repulsions in a tetrahedral arrangement, which has an ideal bond angle of 109.5 degrees. The tetrahedral shape is very common, especially in organic molecules. An example is methane, the simplest hydrocarbon. With one of the four electron groups a lone pair, the shape is trigonal pyramidal. Since a lone pair exerts greater repulsions than a bonding pair, the bond angle is less than 109.5 degrees. Ammonia is a common molecule with this shape. Its bond angle is 107.3 degrees. When two of the four groups are lone pairs, the molecule has a bent or V shape. Two lone pairs exert greater repulsions than one, so the bond angle is reduced even further. Water, for example, has a bond angle of only 104.5 degrees. Four electron pairs fill the valence level of a period 2 atom, but one from period 3 or higher can use d orbitals to expand its valence level and bond to more than 4 atoms. 5 electron groups minimize repulsions when they point to the corners of a trigonal bipyramid. Here we find two ideal bond angles. Equatorial groups lie 120 degrees apart, and axial groups lie 90 degrees away from equatorial groups. When phosphorus reacts with excess fluorine, the trigonal bipyramidal molecules phosphorus pentafluoride forms. The final common arrangement has 6 electron groups attached to the central atom. Repulsions are minimized when the groups point to the corners of an octahedron, and thus lie 90 degrees apart. Sulfur hexafluoride has an octahedral shape.